Today, we're getting into something pretty fascinating, maybe even a bit unsettling, adversarial AI.
Mm-hmm.
And this isn't your standard software bug hunt, right?
Yeah.
It feels more like, I don't know, a clever trick, almost psychological, aimed at AI itself.
That really hits the nail on the head. Adversarial AI, at its heart, is about techniques specifically designed to compromise or fool AI models.
Okay.
And the key thing is how. It uses deceptive inputs, maybe slightly manipulated data. It's not like typical hacking looking for a coding flaw.
Right.
It actually exploits the very way these AI systems learn and process information, basically twisting their interpretation so they get things wrong or sometimes even leak sensitive stuff.
So, like you said, an optical illusion, but for the machine.
Exactly, an optical illusion for the machine.
Okay, that's wild. So how does that actually work? I mean, how can an input, maybe a picture or a voice command that looks totally fine to you or me, complete fool an advanced AI?
Yeah, it seems counterintuitive, doesn't it? But the thing is, machine learning models, particularly the big ones like deep neural networks, they are surprisingly vulnerable to these carefully crafted inputs.
Carefully crafted, meaning intentional.
Oh, definitely intentional. These aren't just random noise. They specifically exploit let's call it the statistical nature of how AI learns. See, models learn patterns based on probabilities, on correlations in the data. They don't understand things like we do.
Ah, okay. So it might recognize a cat based on a bunch of pixel statistics, not because it knows what a cat is.
Precisely. So if you cleverly tweak those pixel patterns, just slightly, in a way we might not even notice, the model's calculation might suddenly shift. And it classifies that cat as, I don't know, a car or something completely different, even if visually, to us, nothing really changed.
So it's less about tricking its thinking and more about messing up its calculation. Is that a fair way to put it?
That's a great distinction, yes. Yeah. It's about the calculation based on those learned statistics. So what's the weak spot they're hitting, mathematically speaking?
Yeah, what's the underlying vulnerability here?
Well, fundamentally, these models create what we call decision boundaries. Imagine invisible lines or surfaces in a very high-dimensional space.
Okay, separating different categories, like cat versus dog.
Exactly. Separating cats from dogs, stop signs from speed limit signs, whatever it learned. Adversarial attacks work by finding data points, finding inputs that lie incredibly close to these boundaries.
Right on the edge.
Right on the edge. So small perturbations, tiny, often completely unnoticeable changes to us, can be enough to push that input just over the line.
I see.
It causes the model to jump from one classification, say cat, to another dog. It's like the AI is walking a tightrope, and a tiny, invisible nudge sends it falling to the wrong side.
That's a really good way to picture it. Yeah. So, okay, how do attackers actually find those perfect little nudges? How do they engineer them?
Right. It's not random guessing. They use some pretty clever techniques. One major one is gradient-based optimization.
Okay, gradients, like the slope in math class.
Sort of, yeah. The model uses gradients internally to adjust itself towards the right answer. Attackers can actually use these same gradients to figure out which tiny changes to the input will have the biggest effect in confusing the model. They essentially use the model's own learning signals against it.
Wow, okay. Turning its own tools against it. What else?
Then there's what you could call perturbation analysis. This is really the art of applying those minimal, often imperceptible changes.
Finding the sweet spot.
Finding that one critical pixel or that tiny tweak in an audio frequency that flips the classification. Maximum impact from minimal, invisible change.
Like changing a stop sign to look like a yield sign just for the AI.
Exactly that kind of thing.
Yeah.
And finally, they also use pattern exploitation. They figure out where the model's understanding of patterns, learned from its training data, is maybe a bit brittle or incomplete.
So they find the gaps in its learning.
Essentially, yes. They exploit the blind spots in how it generalizes to new, unseen data. They craft inputs that fall into those blind spots.
This is really complex and subtle stuff. So bringing it back to us, to you listening, what does this mean for how we interact with AI every day? If AI can be fooled like this, how much should we really trust its outputs, especially when it's doing important things?
That's the million-dollar question, isn't it?
So just to wrap up the main idea, adversarial AI isn't about breaking the code. It's about targeting the AI's perception, its statistical mind, you could say, by manipulating what it sees or hears.
That captures it perfectly. It subverts its interpretation of reality.
Right.
And that leaves us with a pretty important thought, I think. As AI gets woven deeper into everything, driving cars, helping doctors, managing systems, where how critical do we need to be? How much should we question the decisions made by systems that we know can be swayed by these tiny deceptive inputs that we can't even see?
A crucial question indeed. Something to definitely keep thinking about.